All right. Hey, AP Stats guys. This is a quick review for Unit 3 before your test. So, number one, a marketing company wants to know what you think about their product. So, they divide the population into groups based on age and took simple random samples of each age group. This is an example of what kind of sampling you should reply with stratified. Random sample. One quick giveaway is first of all, you notice that they're dividing the population into subgroups. And if you're taking a simple random sample of each one, that's a giveaway. It's stratified. If by contrast you took a census of one of the small subgroups or many of the subgroups, you would think cluster. Also, think about what each group looks like. Each group looks like itself, meaning all young people, all middle aged people, all older people. You're dividing it so that it all looks like itself. If you broke them up into clusters, and the each subgroup would be resembling the greater population, you'd have more diversity in each subgroup. Number two, January 2005 Gallup Youth Survey. Telephoned a random sample of 1,000 U.S. teens and asked them to name their favorite movie from 2004, and they responded, Napoleon Dynamite. I had the highest percentage, with 8% of teens ranking it as their favorite movie. What is true? The population that they're trying to find out things about, population of interest, is all U.S. teens. That seems true. 8% is a statistic and not the actual percentage of all U.S. teens who would rank this movie as their favorite. That is also true. This sampling design should provide a reasonably accurate estimate of the actual percentage of all U.S. teens who would rank this movie as their favorite. There's no real flaws in how it's worded, so I would also rank that is true. So we have to account for all three. Number three, more cats are being diagnosed with attitude problems than they have in the past. A researcher identified 50 cats without attitude problems and kept a record of their diets for several years to see if any had developed attitude problems. This is an example of a prospective study because even though this took place in the past, before the study started, they identified their subjects and kept records throughout. What is a placebo and why is it used? A placebo is a fake treatment or pill designed to make people think they are being treated even when they are not. This should be primarily used for blinding. Blinding would be the best answer for that. 5. What statement about bias is not true? Randomization will eliminate bias is definitely not true because we all know everybody has some type of internal bias either they are aware of or they are not aware of. So that is not true, but let's keep going. Bias data comes from your sampling method, likely to produce samples that does not represent the population. Well, it could come from bad samples, but even good samples still have bias in them. The idea of randomization is just to spread out your bias into all samples evenly. Bias is reduced when the sample size is larger. That is definitely true. So 1 is going to be our only answer there. Why is blinding used in experiments? Well, blinding is used just to reduce bias. Blinding is used so that you minimize the amount of bias in there, even though there will be always some bias present. 7. Burger Royalty now serves a vegan burger and wants to know what people think about it so that they give a free sample to all customers and ask them to fill out a form rating it from 1 to 10, with 1 being nasty and 10 being so good you're excited to try other vegan options. 72% of the people filled out the survey and 88% responded positively to the vegan burger. What is true? The population of interest is not all vegans. They probably want to know just the opinion of the people who are shopping at Burger Royalty. 2, the survey suffers from non-response. with about 72% of the people responding, you should think that you're getting a pretty high response rate, so you're getting a good picture of that. So I would say non-response does not apply with a high number of people responding. Since that 88% came from a sample, it's a parameter, not a statistic. You should actually think it's a statistic. If it comes from a sample, it's a statistic, not a parameter. All of these are bad. Comment on each sample design as valid or criticize as to why it's not valid. Also identify what type it is. So code every member of a population and poll 100 randomly chosen members. That's a simple random sample. And generally, that should work out fine. Code every member of a population and poll 25% of them chosen randomly. That's still a simple random sample, but the problem is you're sampling over 10% of the population. You run a risk of you run the risk of polling the same person more than once, which is a problem. So this would not be valid. Divide a population by race and select 50 individuals randomly from each group. Should be a stratified sample. Remember, each of those groups looks like each other instead of the greater diverse population. That would be a stratified random sample. Deliver a survey to a group and count the opinions of those who return it and ignore any who don't complete it. That's a volunteer. Response sample, which is a problem. That would probably lead to some type of non-response bias. Select 5 classrooms in a large high school and poll everyone in them. Keyword everyone. We're thinking this is a cluster. 9, in an observational study, if there's a lurking variable, which of the following statements are true, we're definitely not talking about correlation coefficients in this chapter. One of the variables is confounding is interesting, since lurking and confounding basically mean the same thing, but C is the basic definition of lurking variable. The investigator cannot separate the hidden variable or the lurking variable had on the response or explanatory variable. What I want you to think about lurking and confounding is that lurking you're going to see a lot more in observational studies, confounding in experiments. And it just means in confounding in an experiment mostly means it's something that your experiment didn't control for but affected the variables. And these are both wrong too. Which of these is not necessarily in experimental design or not necessary for experimental design? Blocking is not necessary, although sometimes it's a good idea to call for it.